So before we start talking about the steam tables or the sources that we can get physical property data from, again, just a quick recap of what we have previously. So we explained this PV diagram. Why this one is called PV diagram? Because the y-axis is pressure, x-axis is volume or a specific volume. And if you remember, so we have this line, this region, any point in this region is liquid. This is the critical point. Any point here is vapor. But one thing that may come to your mind when we say we have PV diagrams, so this diagram represents the relationship between pressure and volume only. But if you remember, we have some lines we displayed in the previous lectures. These lines, these red lines, that we have horizontal line here, and then we have change in this line. So only we have horizontal in the two-phase region. Okay. Each of these lines represent temperature. So yes, this diagram is PV diagram, but still you can get the information about the relationship between pressure temperature, between volume temperature, by just displaying the lines that represent the temperature. And not only temperature, we can have lines that represent the enthalpy. So now each of these lines you have right now represent a certain enthalpy value. Okay. Also we can have values for the entropy. Okay. If you put all of these lines together, so this will be everything we have. So this is a diagram, PV diagram. Y-axis is pressure, x-axis is a specific volume. But again, you can find information about temperature, you can find information about enthalpy, you can find information about entropy, because there are some lines that represent any of these properties. Okay, and this will be one of the main sources that we can use to find like any physical property you have. So I can tell you I have pressure 1 atmosphere, for example, or let's again, I have pressure 1 megapascal, I have a specific volume 0.1. So just by this intersection, these two lines, you can find what is the pressure, what is the temperature at this condition, what is enthalpy at this temperature and pressure, what is entropy. Clear? This is one of the main sources, or the first sources that we can use in order to find the interrelations between this property. Or you find any other property if you know, like temperature, pressure known, enthalpy, pressure known, so whatever we have. Okay? But the thing is, do you think a shape like this one, this is something easy that you can use or obtain data from, or this would be difficult? We have several lines, especially in this area. Even we have each color represent one property, but it's very different to differentiate between them. This is why we are replacing this with appendix similar to what you have right now. Okay, so now we have appendix. In thermodynamics, we will use appendix A. This is the first appendix that we will use in this diagram. And again, the PV diagram that we just showed, it have one area for the subcooled liquid, region for the two-phase systems, region for the superheated vapor. So this is why we have two tables that represent the steam liquid and steam vapor. One table represent, or you can give you any data for the superheated steam, one table for the compressed liquid. So we have one table for this region, one table for this region, and two tables for this region, steam, pressure, and saturated liquid and vapor mixture. Okay, so the idea is clear so far. So again, we have diagrams, we have figures we can use. It's there, it's in all textbooks, but sometimes it's hard to use them. So this is why we can use these tables. So steam tables, we have 4 tables. Table A1, if you just open it, this will be what you can see. If you don't have hard copy, you can open it from Canvas, or you can check if anyone had a hard copy, you can see it with her. So this will be the table that we have, table A1. So this is table A1. This one for saturated steam. Okay. And if you go to the second table, table A2, this also for saturated steam. So we have A1, A2, both of them for saturated steam. So what's the difference between them? Why we have two tables? Because the first one, table A1, this one is pressure increment. The first, or the numbers are arranged by pressure. While table A2, this one is temperature increment. It's arranged by temperature. So I can tell you I have saturated steam, for example, and the pressure is 1 bar. Find the properties for saturated steam at 1 bar. So the pressure is given, so it's much easier for you to go to A1 when the pressure is given. Look for this pressure, 1 bar in this column, and then you can find the property. You have saturated liquid. This saturated liquid at 25 degrees Celsius. So now the temperature is given. So go to appendix A2 with the given temperature 25. So see the properties that you have. This is the only difference between them. They contain exactly the same data. Just one you are using it if you have pressure is given, which is A1. The other one we are using it if temperature is given, which is A2. But both of them can be used for saturated steam, saturated liquid, saturated vapor. Any one of these two phases, saturated liquid or saturated. It's called saturated steam, but also we can use it for saturated liquid. So A1, A2, we can use these two tables to get any information for saturated liquid, saturated steam. We have a lot of chairs here. One of them, if you have pressure is given, A1. The second one, if temperature is given, A2. Okay. So what are the other columns we have here? So this one, this temperature and the pressure, these two columns represent saturation temperature and pressure. So if you have pressure, let's assume 0.02 bar. What is the temperature at which phase change will happen? This will be the saturation temperature of the boiling point. This is the temperature at 0.02 bar at which phase change will happen. Here, if I tell you, like table A2, so again, this is the same thing. This is saturation temperature and pressure. Pressure. So I can tell you, okay, what is the pressure at which phase change can occur at 30 degrees Celsius. So this is 30 degrees Celsius, so this is the pressure. If you have 30 degrees Celsius, 0.0425 bar, at this condition, phase change will occur for water. Clear? So these are the first two columns, temperature and the pressure. These are the saturation temperature, saturation pressure. And if you can see, the relationship between them is directly proportional. Increasing the pressure, the temperature, saturation temperature will increase as well. These two columns represent the specific volume. How I know? Because you see here V hat, this symbol, which represents the specific volume. These two columns represent specific internal energy, which is U hat. These two columns represent specific enthalpy, H hat. Last two columns, specific entropy. S hat. So these are the columns. So we have two columns for specific volume data, two columns for specific internal energy, specific enthalpy, specific entropy. All the data here are extensive or intensive properties. Intensive, because all of them are specific properties divided by mass. Okay. So now if I have two columns for specific volume, so what is the difference between each one of them? So if you have two columns for a specific volume, here you can see we have superscript V. This superscript V represents vapor, saturated vapor. And this we have it here. So this is V, saturated vapor. This is V. Oops. So we have this V. So all of these superscript V, this means this column for saturated steam or saturated vapor. And the other side we have this L, 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 there's one L missing, yes, L, all of this L so this represents, these columns are for saturated liquid. So we have temperature and pressure, specific volume, specific internal energy, specific enthalpy, specific entropy for saturated liquid, for saturated vapor. So any superscript L, this means all these numbers for saturated liquid. Any superscript V, this means all these numbers for saturated vapor. Clear? And similarly for A2, if you go to A2, you will see the same thing. This is specific volume for saturated liquid, specific volume for saturated vapor, specific internal energy for saturated liquid, specific internal energy for saturated vapor, specific enthalpy for saturated liquid, specific enthalpy for vapor, entropy for liquid, entropy for vapor. Clear? Any questions so far? Let's go back to that. So again, if I tell you I have saturated steam, and again, all of these tables for steam, so all of these tables for H2O. If you have another substance, there are other tables for the other substances, but they have the same approach, the same idea. If you understand one, you can use any one of them, okay? And this is the only one, by the way, we'll use this semester. Okay, so if I tell you I have saturated vapor at 0.05 bar, what is the specific enthalpy for saturated liquid or vapor? Let's assume we have saturated liquid at 0.05 bar. Okay, so what will be the specific volume? Anyone can find it? Saturated liquid 0.05 bar. Yes. So again, go to the pressure. So start at this one. This is the pressure column. Pressure is given, so I will use A1. Look at 0.05 bar. This is 0.05 bar. So the saturation temperature at this one is 32.88 degrees Celsius. Then you can go to this column. This will be the specific volume for saturated liquid at 0.05 bar. The specific internal energy for the saturated liquid, specific enthalpy for the saturated liquid, specific entropy for the saturated liquid. If at the same condition, 0.05 bar, but instead of liquid you have vapor, so this will be the data you have. If at the same pressure value, but you have saturated vapor, this will be the specific volume for this saturated vapor. This will be the specific internal energy. This is the specific enthalpy. This is the specific entropy. So one of the mistakes that we see in the exams, so the example says we have saturated liquid, but you mixed with the columns. So make sure that you are at the row that represent the given pressure and at the column that represent the phase. If you have liquid or if you have vapor. Clear? Okay. And if you have temperature given, then don't use A1, but we will go to what? A2. Okay, because A2, this is the one has easier temperature increments. So let's assume at 20 degrees Celsius or 15, so 15 degrees Celsius. The saturation pressure, this will be the value of the saturation pressure. Okay, this is specific volume. This one represents specific volume for liquid or vapor? Liquid, because here I have L at the top of the column. This one, specific volume for vapor. Here, internal energy for liquid, internal energy for vapor. Enthalpy for liquid, enthalpy for vapor. So again, I know how I know it's vapor because here I have V. How I know this column for liquid, I have here L. So see these superscripts. Entropy for liquid, specific entropy for vapor. Clear? So now, how you know the units of each of the numbers you have? In the first row, you have all the units displayed. So if you are calculating specific volume, so any value in this column is in meter cube per kilogram. So how I know this? It's already written here. Okay, so there is no need to think of it. Just see the first row. Here, the specific internal energy, both of them in kilojoule per kilogram. So make sure kilojoule is not SI. So this number should be multiplied by 1000 to be converted to joule. Okay. Then we have enthalpy or a specific enthalpy. So again, this one is kilojoule per kilogram. Last one, specific entropy. This one is kilojoule per kilogram Kelvin. And again, all the units here. There is no need to memorize anything. Everything is there. Just you need to know how to read this diagram. So let's start. This is again table A2. If I tell you find the, let's get some easy numbers. Let's find specific enthalpy for saturated liquids at 17 degrees Celsius. Can you find this temperature in the appendix? No? So what you will do? How?
Estimated, like find the two values and then take.
Exactly. So 17 is not there. What I have 15 degrees Celsius. I have 20 degrees Celsius. Okay. So I know that's for temperature. I have 15. I have 17. This is what I need, and I have 20. And the property that I need to calculate specific enthalpy for liquids in kilojoule per kilogram. So I have it, this number, I have this number, so this is 63. I have no idea what is this value. This one is 83.9. Then you will make interpolation. So in order to find this one, the only thing you have here is to make interpolation. And how we make interpolation? So easy. What we'll have, what is the temperature that is given? 17 minus 15. So this temperature minus this one divided by this temperature minus this one, 20 minus 15, equal the corresponding enthalpy values. So 17, I have no idea what is the enthalpy. This is the property that I need to calculate. So this one, enthalpy of a specific liquid at 17 degrees Celsius, minus enthalpy at 15. So it will be this one minus this one, minus 63, over this one minus this one, 83.9 minus 63. Then from this equation you can find what will be the value we have. Then specific enthalpy for saturated liquid at 17 degrees Celsius. You can calculate it, and the number will be kilojoule per kilogram. Clear? So this is, if you didn't find the number, then you can make interpolation. Anyone calculate the number? Okay, just in case, if anyone calculates, just tell me the number we can find. Okay. 67.2. Okay. Clear? Okay. If you want to make interpolation, so the most important thing is how to put the numbers. So the consistency here is very important, because let's say when you start at 17, so the first number on the right side should be the enthalpy at 17. Then we have minus 15 degrees Celsius. So this one should be enthalpy corresponding to 15 degrees Celsius. Here we have 15, so this number should be enthalpy at 15. Also, if this one is 20, so this must be the enthalpy at 20 degrees Celsius. So this is very important. Okay? If you just mess with this arrangement, then you can get different number, or you can get correct number, but the sign will be different. Okay? And remember that enthalpy, this is a sort of energy. And the energy, it has a sign convention, similar to heat and work. Okay, so they can mess with all the calculations you have in the problem. Clear? Any questions so far? Okay. The third table we have is A3. And this one is for superheated steam. Usually, if you have saturated liquid or if you have saturated vapor, you need to know the temperature or the pressure of it. Just one information is enough, temperature or pressure. But if you have superheated steam or you have compressed liquid, you must know the value of temperature and pressure. Okay? Because if we go back to this, that's bad. So for this one here, if you remember, this is the saturated liquid line. So any point on this line represents saturated liquid. How you can go to this point? If I know the pressure, so I just from this pressure I will move until I intersect with the line, and this will be the saturated liquid at this pressure. If this y-axis is temperature, for example, so at any temperature, thus you can go intersect with this saturated line. So this is the saturated liquid at this temperature. Similarly for saturated steam, at this temperature or at any pressure, you can go to the other side. This will be saturated steam at this temperature or at this pressure. So just one information is enough. Temperature or pressure is sufficient to give you or to make you able to locate the position of this point. But if I have compressed liquid, so this can be compressed liquid. This can be compressed liquid at the same pressure. So if I have this pressure, at this pressure, this can be compressed liquid, this can be compressed liquid, this can be compressed liquid. So I have multiple points can be compressed liquid at the same pressure value. So at what point you need to make your calculations? So I need another information. So this other information can be volume. So I know at this point. It can be temperature. So I know this point. And similarly for superheated vapor. If I have this temperature line, this is superheated, this is superheated, this is superheated. So which one of them I will use? So you need one more information. So for compressed liquid, for superheated steam, you need two information must exist. If you cannot find these two information, you can't use the steam tables. Okay? Let's go to A3. So this is A3 for superheated steam. So this one you can see, we have here sets of data for a given pressure. So all of this data represent the data at 0.1 bar. All of these data we have represent the properties that you have at 0.5 bar. Okay, so the first thing is to locate what is the pressure you have, what is the temperature you have. So let's assume I have 0.1 bar and the temperature is 150 degrees Celsius. So this is 0.1 bar, this is 150 degrees Celsius. So this is the properties I have. And all the data I have here, this is specific internal energy, specific enthalpy, specific entropy. Here we don't have L or V at the superscript, right? Because this number automatically for what? For superheated steam, only vapor. Clear? So there is no need to put V or L for this one. Okay. For table A4, this one is for compressed liquid. But we have the same idea. We have pressure, 5 bar, and all the data at different temperatures, but for this pressure value. We have different data for different temperature, but at 10 bar. And again, here I don't have no superscript, because this is automatically, this table is for liquids. Make sense? Clear? Okay. So the question, let's say, if I tell you, for example, I have water, and I give you the pressure. In the problem, I can tell you have saturated liquid at this temperature or saturated vapor at this pressure. So easily you can know that you will use A1 or A2, because A1 and A2 for saturated data, right? But let's assume if I have, I give you the pressure, I give you the temperature, but I didn't tell you if this superheated or if this compressed liquid. So now you may confused, will use A3 or use A4. So this map here, it tells you which one you can use. So basically this one tells you, look for the temperature, the given temperature. If this given temperature is above the critical temperature for the substance you have, which we have appendix also for this one, then you will go to the superheat vapor data. So automatically, if the critical temperature, if the temperature more than the critical temperature, so directly go to A3. So superheated vapor data, this is A3. Okay? But if the temperature is less than the critical temperature, then look for the pressure. If the pressure is more than the saturation pressure, and how you find the saturation pressure, A1 or A2. So remember, if you have temperature, just the pressure value close to it, next to it. If the pressure is more than the saturation pressure, so you will use the compressed liquid data, A4. If the pressure is less than the saturated pressure, then you will use A5. Sorry, A3. There's no A5. Just so keep always this in your mind, because A1, A2, this is very simple, because it will be saturated. You will find it's called, we have saturated liquid or saturated steam. So it's very straightforward to use A1 or A2. So the confusion is A3 and A4. When I can use each one of them. So again, the given temperature above the critical temperature, automatically go to A3. Temperature is below the critical temperature, which is most common. You will use this a lot. So now compare the pressure. Pressure more than saturation pressure at this temperature, so we'll go to A4. Pressure is less than saturation pressure at this temperature, go to A3. Okay, so let's get one example. So let's assume, for example, let's go to A1. Okay, so just for example, if I have this temperature, so again, the pressure in front of it, this is the saturation pressure at this temperature. So if I tell you I have 28.96 degrees Celsius, this is the temperature I have, and the pressure I have is 1 bar. So now the pressure is more than 0.04, right? So I will go to the compressed liquid, A4. At 28.96 degrees Celsius, the pressure is 0.02 bar. Now the pressure is less than the saturation, so I go to A3, saturated vapor. Clear? So this is how you can find the saturated temperature or saturated pressure at which condition based on the given information you have. Clear? Any questions? Okay. Last part we have here in this one, let's get back to A3 steam table. So now we see we need to make interpolation sometimes, right? So now let's assume if I tell you an example, I need to find the value of specific enthalpy at 0.4 bar and 220 degrees Celsius. I need to find the enthalpy at 0.4 bar, 220 degrees Celsius. Do we have this pressure there? We don't have 0.4. We have data for 0.1 bar. We have data available for 0.5 bar, right? But there is no data available for 0.4. So what you need to make for the pressure interpolation? Then, do we have this temperature given? No. We have 200. We have 250. Then you need to make interpolation at 0.1 bar to see what will be the enthalpy at 220 degrees Celsius at 0.1 bar. Repeat it at 0.5 bar, make interpolation here to see what will be the enthalpy at 220 bar at this one. And then you make the pressure interpolation. So how many interpolations we need? 3. Okay. If you have compressed liquid, if you have superheated steam, pressure and temperature are not there, then you need 3 interpolations. Okay. So instead of doing all of these things, what we have, and I will share this one with you, we have this Excel file. You can use it in your calculations. I will give you in the exams as well. Okay, so here, enable contents. Okay. So we have this Excel file. Here we have like 3 tabs, 3 important tabs. This one is saturated steam by pressure. So this one represents A1. Here we have saturated by temperature. So this is A2. Compressed and superheated, A3 and A4 together in this tab. Okay. For saturated steam or saturated liquid by pressure, again we said you need only pressure or what? Temperature, just one of them, right? So if you have the pressure given, you can go here at this yellow cell and just put the pressure, but the pressure is in megapascal. Oops. So the pressure value, you can see it here. So this pressure value here is megapascal. So you should like maintain the consistency. If the pressure is bar, convert it to megapascal. The pressure in the atmosphere, convert it to megapascal. But this Excel table use only megapascal. Go to this table here, put the pressure you have. Let's assume I have pressure is 5. Press enter, then all the numbers you have here represent everything you need at this pressure. Even if you need interpolation, this Excel file will make the interpolation automatically for you. Okay, it will exactly did the steps that you are doing. The temperature is given, then go to the other tab. This is the temperature. Here the yellow cell, this represents the temperature you have, and the temperature is in degrees Celsius. So any temperature we have, let's say 150 degrees Celsius, and then this will be the properties you have. Okay? If you have compressed liquid, superheated vapor, then you know temperature and pressure. Both of them should be known. Then go to the third tab. Here we have cell for pressure, megapascal, cell for temperature in degrees Celsius. So put any number you have. Let's assume 3 megapascal, 150 degrees Celsius, and this will be all the values you have, even the phase. What would be the phase? This is liquid or this is vapor. So let's assume this is 300. So now you see when I change the 300, now it becomes vapor. Okay? So even you can see what is the phase you have at this one. Okay? Is it clear? Let's do one thing. I didn't check this before, but let's assume if I have 300 degrees Celsius, the saturation pressure 8.588, let's put it 8.588. Okay, so here when I put this one, this is exactly the saturation temperature and pressure. See, it says the phases are identical. So here I have saturated liquid, saturated vapor at the same time. Okay, but it can tell you if I have vapor, for example, it can tell you if I have liquid, it also can tell you this one. So you can use this Excel sheet. Okay, so this can do everything that we are trying to do with the steam tables. But again, the most important thing is to make sure that the units are consistent. The pressure in megapascal, which is different from the steam table you have. The steam table you have is in bar, okay, and the temperature degrees Celsius, which is the same. Okay, I think the other units are the same. The specific volume in meter cube per kilogram, internal energy kilojoule per kilogram, also enthalpy kilojoule per kilogram, entropy kilojoule per kilogram Kelvin. Okay. And sometimes in the problems, you also will see this in the assignments. So sometimes we make rounding of the numbers. So it's okay that we have different numbers. So let's assume in the assignment you have the answers as drop-down menu. So you may face that your answer is not one of these answers listed in the menu. So just select the closest one to it. Okay? And also for the exams, if this happened, so it's not necessary to have exactly the same number. Because of the rounding, just the closest number you can select it. Clear? Any questions?